Vectors Part 2, Geometric Vectors. In Part 1, we talked about algebraic vectors, or how to manipulate vectors algebraically. In this case, we're going to use pictures, which I'm going to call geometric vectors. So recall that a vector is something that has a magnitude or length and direction. I'm going to call this first vector vector u. We usually put vectors with a little arrow on top. And then I'm going to draw another vector v with a different magnitude and a different direction. Now, what if I wanted to add these two vectors together? First of all, why would I do that? Well, I like to think of vectors when I'm learning in terms of forces. So imagine that there are two people pushing on a box. I have person who's represented by vector u, and another person represented by vector v. Just by looking, can you tell which person is pushing the box? This is an imaginary box. Which person is pushing the box with a greater force? If you said u, you are correct. U has a bigger length or a bigger magnitude. So that would correspond or relate to a bigger force. Now, U is pushing roughly, let's say, sort of northeast, and V is pushing kind of a little bit south of east. What happens if these two people ganged up together in the box and pushed at the same time? In which direction do you think the box would go? Well, we talked in the last video about how we could move vectors. So, as long as I don't change the magnitude, the length, or the direction, and my length is a little bit off, I'll try to draw it roughly the same. This is about u. And then I'm going to draw v again, and what I'm going to do is I'm going to put these two so that their tails touch each other. Like this. Now imagine these are two people and they're pushing a box. If you had to guess, which direction do you think the box would go? And how hard is the box being pushed? Well, I would guess it's going in between the two boxes and probably maybe a little bit more towards U than V. Why would I think that? Well, U is pushing harder. So I'd expect more of my force to be in that direction. Now, I drew a guess, but it's actually a really good guess. And I'm going to redraw this down here, but in a slightly different fashion. So I'll put my U here again. And so this first picture was just, two people pushing to give you an intuition of what would happen. But algebraically, or actually geometrically, what I would do, instead of putting the two tails together, I would take U, for example, and then I would move V so that its tip, once again, its tail, would be at the very tip of U. So I'd start U down here, and I'd draw it up to here, and then I'd restart V where U ends, like this. And then the vector that I want, U plus V, because that's really what's happening, right? My two forces or my two vectors being added. The vector U plus V is the vector that takes the shortcut across from where I started to where I finished. Just like that. Let's do another example. I'm going to call these vectors A and B this time, if you would like. You can stop the video and try to guess what the answer will be before I get to them. But let's do A plus B to start. So if I have A plus B, I have two forces or two vectors being added together. I'm going to redraw these. I'm going to try to draw them well. So let's draw this as A. I'll restart it. But instead of moving B down here at the tail, I'm going to put the start of B at the end of A like this, and then try to draw it pretty well. I got a little bit off, but it's pretty close. And then the vector A plus B is the one that starts with A, ends at B, but takes the shortcut across. Let's do some advanced looking ones. What if I have U is this vector? I'll just draw a little one like that. And then V is, let's point it in a different direction this time. Let's go this one, and a kind of little short one. And we'll do 2, maybe 3 examples with these U and V's. Let's start with the vector U minus V. How would I do U minus V? Well, I'm going to do U again. Here's my U. And then I want to do U plus the negative of V. Now, what do you think the negative of V is? Well, the negative of a vector simply points in the opposite direction. So U minus V is the same as U plus negative V, and then I can just add my vectors like I did before. So here's my U, and I'm going to start my negative V at the end of U, like that. And the vector that I want starts where I started, ends where I end, but takes the shortcut across. I should write this in red so it matches a little better. Okay, let's do the same U and the same V. But let's do this. What if we do 2U plus 3V? How would we do this? What do you think? What do you think 2U is? Well, this is U. U is just doubled to get 2U, right? You can think of 2U being U plus U. And then 3V, which I'll draw up here, would be 1, 2, 3 of the V's. So how would I draw 2U plus 3V? Well, let's simply do 2 U's. There we go, there's my 2U. And then I'd take my 3V and start it at the end of my 2U. And then, as always, to get the vector that I want, I start where I started, I end where I end, and then I take the shortcut across. And that is my vector 2U plus 3V.